Hello everyone and welcome to the first episode of Binary Wizards' educational series. In this video I'm going to be talking about the xSQL tooling family and in particular IDASQL. In future videos I'll cover the rest of the tooling family like Binary Ninja SQL, ghidrasql and whatnot. So what is the xSQL family? In short, it's a set of tools designed for AI agents to have a natural SQL interface and live interface to your reversing tool of choice. So maybe you think about when I mentioned the word SQL, you think we're gonna export stuff and import stuff. That's not the case at all. This is a different approach where we give it a live interface. So instead of learning how to use APIs, or introducing individual functions like people who use MCPs, they have a bunch of tools to say list functions, update functions, rename functions, etc. Here the xSQL tooling takes a different approach where if we want to interface with IDA, we just simply issue SQL queries and they take effect immediately. And it so happens that LLM models or AI agents are proficient in SQL, and so they can naturally work with your database without any issues. And as you'll see, once you start using the IDASQL or the xSQL tooling family, you will notice that your agent will be extremely token efficient, and also it will be able to do so many things beyond what you have been used in basic MCP tooling and so on. So in this video, I'm gonna keep it short and focused toward introducing IDASQL in particular, and how to install it, and the basic use cases. In the future, we'll talk about different scenarios, how to recover source code fully, how to recover types, how to compare binaries, or even how to work completely headlessly between Binary Ninja, Ghidra, and IDA at the same time to exchange information, for example. Or even how to use multiple machines to do concurrent analysis using the same toolset that I'm teaching you. So if you haven't used IDASQL before, this is your chance now to learn how to set it up and get started with it. All right, let's get started. Okay, so installation. So the first thing we're gonna do is install the accompanying skills. So because IDASQL is a different approach, it's not an MCP, it's a CLI and an IDA plugin in this case, we need to teach the coding agent how to use it. Now, can the coding agent figure it out without installing the skills? Of course, they can. But if we want the best performance of IDASQL, we need to either point it to a specific prompt or a specific set of well-curated skills. So this is where the repo IDASQL skills come into play. And we're just gonna quickly show you how to install it. Now, if you can use any coding agent of your choice. I'm gonna be using Claude Code. I could have equally used Codex, OpenCode, Py, anything you like, as long as they can read a markdown file or they natively understand skills. Alright, so first thing is I'm gonna launch my Claude and just copy this to add the marketplace. This skills are bundled under plugin, and so the plugin is just could contain multiple skills and agents and whatnot. So here I kept it simple. The whole marketplace is dedicated for one skill set, and that's it. So I just say plugin marketplace add. First thing we do, just add that marketplace, and you get okay, we added that marketplace. Now the second thing I'm gonna do is browse inside that marketplace to install the skills. So again, /plugin, we're gonna go to marketplace, and now because we added it, in the future once we add Binary Ninja, we'll see Binary Ninja or Ghidra. And remember, what I'm showing you applies to the different tooling. So today you're learning IDASQL. You can immediately after this video use the same approach, same technique, same prompts to work with Ghidra equally or Binary Ninja. So here in the marketplace, we're gonna select one plugin inside it, browse. We're just gonna hit enter to install it. So install for you, which is for the whole user. It's gonna be available across all those CLI sessions. And here it is. Now we can simply say /reload, for example, plugins or skills. Here we go. All right. And then now that's installed, I can, for example, type /skills. And we see here the plugin name and the corresponding skill. So if we had namespace collision, if we had binary ninja, we would see as well bnsql : and skill name. So this is an indication that we have the skills installed in our Claude code. So now if I exit and try again, if I restart it, I should be able as well to, at any point, just know that the skills are still available. So this is the first step in this equation. The next step would be to install IDASQL itself. And that's where the other repo comes into play, IDASQL. And here we can either build from source or simply grab a release. So if we grab a release, we'll notice we have a couple things. So first thing is we have the CLI and we have the plugin. It's important to know the methodology. So the CLI allows you to work completely headlessly. You will not see IDA. And the plugin is a collaborative mode where if you already had IDA open, you can use still the AI and the plugin is that bridge. And again, remember, there is no mention of MCPs. You don't have to configure MCP. This is way superior than MCP. And of course, don't take my word for it. Play and experiment and you'll see by yourself. So first thing is we just download the binaries, and then if I go here and let's say go to IDASQL CLI, I have the different binaries for the different platforms. So here I'm gonna go to my IDA installation, and this is my IDA installation. This is the CLI. So the CLI has to be deployed. So the IDASQL exe has to be deployed next to ida.exe because it requires idalib. So it has to find idalib. And by convention, it has to be even next to it, next to the kernel. So I already have it here. I can also just copy it. Let me see what version do I have here first. Could be an older version. So let's just override it. Just say here, and let's just rename this one. And then we can take the plugin. So as well, plugins. Let's just remove the older one and copy the latest build here. Here we go. And now I have installed both of them. One final step is if you're gonna use headlessly, it's best to have IDA in the path. So if I say where IDA, here I have two IDAs in the path. I have two path environment. I just have to make sure that the path environment has IDA. Therefore, let's say if here I can say where IDASQL is picking the one from the beta here. So I'm gonna edit my path environment real quick and make sure it's pointing to the production IDA. At the time of recording, IDA 9.4 is not released, so I'm not gonna be using it. In my environment variables here, I'm gonna just clean things up here and add just IDA. Here we go. Now if I start over, for example, if I go to temp and say where IDASQL, here it is. If I say IDASQL, I can see it. And that's all I care about, basically, just to be able to invoke it. And why? Because the coding agent will need to invoke it seamlessly as well. And so that's it. Now we have installed both the skills and the plugin and the CLI. So if we go back here now, and this is my folder, this is the demo I'm gonna show you. So now if I say Claude, for example, already now the skills are there and IDASQL is accessible here. So now we can start using it. So first thing is I'm gonna show you how we can work with it headlessly, meaning I'm not gonna open IDA. Then we're gonna transition to how we can use it with IDA. Alright, so let's go back to the drawing board and discuss some concepts. Most people only heard about MCPs and whatnot, and they can only think in the terms of MCPs and so on. So here the approach in IDASQL, we're gonna be using a CLI. Now the point is, it's not for us to manually drive the CLI. Instead, as I said earlier, the skills and the coding agent will work together to drive the CLI. Now, how does this whole thing work? The CLI and the xSQL tooling family can be invoked either in interactive mode, where you can issue queries by hand, or in server mode, where the protocol of choice I picked up is JSON over HTTP, which is basically what MCP as well shows. This is not rocket science here. But the difference here is once we have my own custom protocol running at a random port of my choosing, or the agent's choosing, we can run the CLI multiple instances with zero configuration. The skill will instruct the coding agent how to run the CLI. So for example, what we'll be doing next is say, hey, connect to this binary. So then it will say, okay, I'm gonna run IDASQL in HTTP server mode, keep it in the background, and then now if we wanna do any SQL queries to look at the database, we're just gonna use any HTTP client to talk to it. So that's where we are breaking away from MCPs and instead choosing that flexibility over the rigid MCP and whatever it stands for. With this, we can have hundreds of headless sessions. We can analyze hundreds of binaries all at the same time. We can quickly interoperate between IDASQL, Binary Ninja, pdbsql, clangsql, all the SQL family. And so now what you see me doing is using the special skill, which I called connect, and that's the entry point. This is how it tells the agent, if I want to look at the binary, then run IDASQL in a special mode to do that. Now, if we had IDA open, the same skill, the connect skill, can tell it how to talk to an already open IDA instance. And we just need to tell it what's the protocol, or what's the port, or what's the endpoint, and so on. So you see it's pretty intuitive, especially for agents. All right, let's demystify this and get to it. Okay, so in my folder here, I'm inside this the SQL demo, and I have a binary, a bunch of them. In fact, I can analyze all of them at once. So the first thing is, I'm gonna pick a random binary. Let's say this NTFS info. So remember, we have skills/skills, and the skills are already loaded. And right now I only installed IDASQL, so we can already type example IDASQL connect. Now I don't need to put the prefix because it's a unique skill name for now. But if I had Binary Ninja and IDASQL and ghidrasql, then it's best to specify the prefix. So for now, I can just even say /connect. And that's how I get started with IDASQL. Since I'm starting headlessly, as you can see, I don't have any IDA instance running. So I will just point to a file name. So I'm gonna say something simple. Again, remember here, this is the first basic workflow. It's not customized, it's vanilla installation. So eventually, if you find yourself repeating commands, what you would do is just simply start writing agents or slash commands and whatever you want. I'm using vanilla installation. Not even a single MCP is configured for me right now. And it's best as well to have a vanilla experience so you don't have collision and confusion. You don't have your context eaten up by so much junk and so on. So really this is a fresh, clean installation. I don't need anything more than the basic client. So we say /connect, which is an IDASQL skill. All you have to do is say, hey, connect, and then we can say, please open ntfsinfo.exe in the background and keep it. We can then say, for example, and tell me how many functions it has. And by asking this initial question after we tell it to connect, we are kind of probing to see if everything works nicely. And then that's it. So what you will observe now is, say, okay, I'm gonna look for IDASQL. I found it, and here it is. Now I'm gonna just start it in the background, and here it is. It says I'm gonna open the file in the background in this port. Waits for it. Once the file is analyzed, it will tell me the answer. It has, for example, 399 function. It's ready. And now the key is your agent manages how many connections and instances and whatnot. We can see here, if I hit down and clone, this is what we are dealing with right now. We're dealing with an IDASQL instance at localhost. Of course, we could have started the server somewhere else in a sandbox, etc. You have to know what to sandbox, what not to sandbox. Right now, I'm dealing with safe binaries. I don't have any issues. All right. So this is basically what's been running. I can also ask it to open another one. I would say also, now I don't have to invoke the /connect. It already knows. So if I mention the word connect, it knows. I would say also connect to errordev.sys, here, for example. And then I can now do multi-binary analysis. I can say, show me a table comparing both of them, the driver and the exe, and tell me how many functions and strings they have side by side in a table. And now I'm driving two binaries at the same time, naturally, by just speaking to it. And you notice how fast it will be, and the speed up or if it's slow or fast depends on just how fast IDA is. It's not, and how fast the agent is, essentially. So how fast is the model gonna respond? So here it is. I have those two binaries headlessly being analyzed, of course. So okay, this one has this and so on. Now I can refer to the exe and the driver in my analysis. Where's the main function in the exe, and can you also decompile the driver entry for me? Now that's where we specialize a bit, and we can, just to make sure the model is gonna perform nicely, we can nudge it to use specific skills. So I'm gonna say /decompiler. That skill, I'm gonna go over the skill, I'm gonna pause a bit, go over the skills, just give you a high level understanding. But I'm nudging it to make sure it knows how to use the SQL tooling, essentially. Of course, the agent and the model, if they're smart, they can figure things out on their own. So I ask it to discover where is the main function and what is the decompilation of the driver entry. So here, okay, I found the main here, it's located here, and so on. For example, I can say, let's deal with this in the driver. With respect to this function, use the annotations and decompiler. For example, we can say rename our local variables and recover the types, and show me a clean decompilation of this function. We can also nudge it with the /types skill. Now here what I'm doing is I'm asking it to properly decompile, rename, recover the types, and show me a clean decompilation. And now we can see that the model actually loaded the skill on demand, which is the annotation skill, which teaches it how to do what it needs to do, and also it loaded the type recovery strategy or skill. Now it's figuring out everything. This is where the SQL magic comes into play. It's discovering whatever it needs to do, like the local variables, the functions that are being called, global variables that are referenced. Now we can hide the output of the tools. We can change the verbosity, configure our agent not to show us all those raw output, but it's not a big deal. We don't have to worry about that. Now here again, as you can see, the weight is just the model is slow. If you have or can afford a faster model, say the fast, or for example in Codex you have the Spark GPT-5.3 fast, and in Codex you have it fast, or maybe even the Chinese models are pretty fast as well. They respond quicker. For example, DeepSeek is fast. But meanwhile, let's just take a look at the skills and discuss the skills on a higher level. What I'm explaining is applicable for Binary Ninja and Ghidra equally. So we have, for those tooling, we have a bunch of skills that I have properly organized and created. So the connect skill is our starting point. We need to invoke the SQL family, the xSQL family. We should say connect. Once we connect, we should see success or failure. After that, it depends on what we want to do. If we want to do disassembly, so we're working with obfuscated code, or whenever we don't have functions, normally we cannot decompile unless we use like the programmatic decompilation, like decompile range and whatnot. But from the user interface, we don't have decompilation. So let's say you're dealing with non-functions, just snippets. You can nudge the model by saying use the disassembly skill. If we want to nudge the model to work with data, segments, strings, tables, then patching bytes, dumping bytes, introducing bytes, we can say use the data skill to whatever, load the binary file here, get the shellcode from disk, put it in the IDA database, or grab the bytes from IDA, put them on disk, for example. If you're looking for symbols, anything, types, anything, like across the whole entities, you can just say use the grep skill to, for example, search for a certain thing. So it will find in functions, labels, types, members, and basically members, fields of structures, and so on. The decompiler skill, you are nudging the model to use the decompiler, and it has a bunch of strategies how to use the decompiler, how to annotate and whatnot. Annotations is a very specific as well strategy skill file to teach it how to add comments, renames, even apply the types, basically change the enums and structures, edit them as needed. As it learns more, it can rename stuff. Types, how to work with the local types essentially. So you can maybe also use it to recover types. You can say, hey, use the types, look at the decompiler and how it's used, and recover the types for me. It will reconstruct the types for you cleanly as if you had the original source code. I'm still working on the decompiler, so on the debugger. Don't come close to this one yet. Storage is an advanced strategy skill. We're gonna talk about it in the future, but it's a way, if you have a good workflow, if you're designing a good workflow, you want persistence. So hey, we want to systematically disassemble the whole program, and we want to keep track in the database. So if we say use the storage skill to implement a certain strategy, then it will use the IDB to store its progress, and it can answer questions, it can put some notes. So really it's up to your imagination how you can leverage that skill. IDA Python, I would say it's a security hazard. It's disabled by default, but it's a fallback. I prefer not to go through that route. But if the model has no choice or it's stuck, it could not go through any other surface, then you can say, all right, fine, use the IDA Python skill. Now, with the IDA Python skill, let's say if you know what you're doing, you can use it to drive IDA end-to-end as well. You can say, hey, load run the script, build the plugin from source, run IDA, run that script. You can use this for full automation as well. Functions, you can work with functions as well. Analysis, it has a bunch of analysis strategies to find security issues. Find certain kinds of libraries, crypto libraries, etc. Of course, these are the base stuff. You're meant to use the xSQL family on top of your workflow, what you're doing. Resource is a simple strategy for recursive source recovery mechanism. We can invoke that skill, say, hey, use that resource skill and give me back the source code fully with type recovery, with a make script, so you can build it again. You will have the source code. You'll have the exact full source code without hallucinations, of course, because we're using the decompiler as a ground truth and so on. All right, so let's take a look here. What happened? So what I asked it is to, this is the compilable recovery of this driver here. Let's see here. And so I asked it to do, and it finished, etc. And then this is what it thinks it can be recovering the source code at. But it also recovered the types, and it turned all the typecasts to nice type recovery. Now, of course, we're working headlessly. I didn't open IDA, but if I save the database and open it, we can see what happens. So what I'm thinking is to ask it to do the same for the main function. So first thing, I'm gonna ask it to release this database. It did not do them here. So okay, so for the driver, yes, make sure everything is annotated, renamed cleanly, and type recovered, adding the comments and so on. Save the database and properly shut down the driver server only. As you see now, this is repeated. So again, that's where you come in. You customize your workflow with slash commands or agents and whatnot. But I'm showing you the basics. Keep the exe up and running, and after that, I want you to look at the main function of the exe and do the same, fully recover it. Use the annotation skills, decompiler, types. And so now I'm and types skill. So here I simply invite it to do the same for the executable. The reason I asked it to shut down the server is so that I can open it visually. Like this, I can now work with the exe headlessly, and the driver, I will open it in the IDA user interface and then reconnect to it and do this pair kind of vibe reverse engineering, so to say. So now what I asked, okay, so for the driver, I asked it to do everything. So here, make sure everything is annotated. Now, it's fine with the typos, no problem. And because I said everything, it's building a plan to go after every function and properly annotate it. But already we can see, because I said everything, is gonna go after everything and do that. But the not everything part is already, this is not something we started with, this is not something we started with, and neither this. So it's already covered stuff, but because I said I don't want to say by mistake, I was a bit more broad in my prompting. It's gonna do better work now, and it's almost like getting back the original source code. So this is gonna take some time. It's fine, we can leave it, and I can open a new session. So if I go and open a new session, we can pick a binary, but this time I'm gonna do it with IDA. So it's gonna be assisted. Let's say TCP this guy here. So if I open this one, and no, let's not cheat. Maybe even there's no PDB. Let's see. Yeah, there's no PDB anyway. So we're dealing with completely undocumented stuff. So here, no, everything is dummy, or like all the relevant functions are dummy. Main function, let's hit the tab. Here we have some dummy stuff, dummy functions. We have some casts, dummy global variables, and so on. This is clearly printf. We can already call it printf. But I can show you how we can do this tandem or assisted. So let's put it side by side here, and let me open a new prompt and put it side by side and put here side by side. Now you might ask why I don't have something integrated in IDA. I don't want to recreate the harness. I'm happy with whatever flexibility. You pick your harness, and my tooling work with any harness you want. So if you want something built in with IDA, right click, go ahead, do it, whatever you like. So alright, so I have this. Now let's connect it. So how do I connect it? First thing is we have to make sure that the plugin is available, and I installed it in the plugins folder, the DLL in the beginning. So here it is, it's installed. Now we can say .help. We can see the stuff we can do. It's pretty much advanced. And by the way, if you like MCPs, wherever, right, I give you MCP. Anyway, so to connect any coding agent with this IDA, I will just say connect, and here I can say .http start the HTTP server. All I have to give the connect is this guy, which is already copied, and Windows is already copied on the clipboard. So I just say connect, and I give it this. So I said connect skill. Instead of pointing it to a binary or binaries in plural, I gave it the connection string. Now there's a relationship between these two. If I have 10 IDA instances, I can just say /connect and give it all the different connection strings. So now IDA is connected. I mean, my coding agent knows what I'm looking at. So for example, now we can ask questions. For example, what is the largest function in this binary? And here I'm querying this one, basically that IDA. And to answer this question, it's very simple from the perspective of SQL, because it's just a select statement. So it's select from the functions order by size, limit 5. Just give me the top 5. And he says, okay, these are the top 5. We can say, all right, so soon I'm gonna add deep links. So we don't have to, all right, this is a big one. Wow. But yeah, I don't think it's going to be problematic for Claude to figure it out. Find me functions, the top 5 functions between 1K and 2K. So here I'm trying to make something more approachable. We don't want to spend time waiting on the model. Again, the slowness is not from the tooling, it's from the model. So here it is. Okay, all of them are named. Maybe this one is worthwhile knowing something about. Let's see, this is fair. Okay, this is a good one. All right. So about this one, or even let me show you, we have a skill here. It's not listed in the table. It's called UI context. We don't have to copy paste if we don't want to. So this is where I am. I can use the skill called UI context. This is like giving eyes to the agent. So now this guy knows what you're looking at. So I can say, for example, let's say fully annotate using the decompiler and recover the types. Then explain to me the gist of this function and add proper comments everywhere. Get rid of the casts, rename local variables, and rename the dummy functions that are called by this function. And let it work. So because I said UI context, you don't see me pasting anything. It knows what we're looking at. and then it will work on that function. Say, oh yeah, you're looking at this function, and let me start analyzing it. Now I'm using Opus 4.6, 4.8 at medium effort. I don't want to burn tokens. It should be good enough. I've used GPT 5.5. Those models are frontier models. They can do a great job. So you can trust you get good job, especially that the tooling is very powerful. So IDASQL or Binary Ninja SQL are extremely powerful. Coupled with a good model, you get extreme good results. So let's take a look at this guy here. So here, it's doing everything. It started the plan. If I said that was a long prompt, but hey, this prompt now drove it to do multi-agent parallel analysis. And so it has multiple agent, annotate this batch. So it took your binary, broke it into multiple pieces already, A, B, C, D, and it started systematically recovering the types. This is what the source recovery workflow looks like. And we can take a peek. You can see here what's happening. So it is systematically updating everything, renaming the functions, the names, adding proper comments. It's gonna eventually recover the types, rename dummy variables. We will get a great result at the end of the day. But here, it's just gonna keep working. This is as costly as recovering the source code. Okay, so now it has everything it needs. Here we are still working in here. It's slowly working its way up. Already you can start to find like print standard out. It's already starting to rename some stuff. It already recovered the function name. Started renaming some variables, but it's not done yet. So it has a list of all those dummy variables. It's gonna figure out everything about them and either recover their types or change their names, apply everything. At the end of the day, we should have extremely great decompilation, but it's gonna take some time because of the model and how slow it is. Just we're waiting on the model. So here you can see it's still renaming stuff. More rename stuff. And if we're not happy with the result, of course, we can always say what we want. Now, if I want to work on something else at the same time as well, I can open a completely new session. So I'm not bound by this session. So what I can do, for example, I can go open a new session here, for example, and we can give it back the same connection string and say connect, and we can already query it. Does this program call or use registry functions? And do you know what registry keys are accessed or opened at least? So here, for example, I'm asking a curious question. We can then invite it to use the cross-reference skill and the decompiler skill. So while one agent, full complete coding agent, is doing a long task, we could open a completely new instance in parallel to talk to the same database and ask more questions. So now what we will be doing is some kind of discovery about relationships, and this is also where the xSQL tooling shines. Eventually, we can generate graphs, we can find relationships, we can find shortest paths between stuff. By asking such a relational question, it has to do some semantic understanding. So the model might decide to decompile the function, read the decompilation. If there's no decompilation, we can invite to look at the disassembly. So it's scouting everything, whatever it needs. There are tables that can give it answers about imports, about cross-references, core relationships, or optimized for fast performance. What we're waiting for really is just simply the model. All the time spent here is the model. So if you're one of the lucky few who have extremely fast inference, then you can have quick answers. And here, for example, I got a nice overview Okay, we have it's using this function and so on. So we can say, for example, can you show me a call graph from the main function leading to the function that uses this server levels registry key? I would like to understand that the call flow, how things are from main to that registry key access. So what I'm asking it is, okay, I saw this, I want to know more. Show me how we reach that. And so I prompted it. And I don't think I have to nudge it again to use the cross references. No need. And the fact that I said like show me a nice graph, I might see an ASCII output graph. I might see something visual, see the main function and how it goes from here to here, etc., etc. Eventually, I can ask it to give me a report, like a PDF file or a report file. All right. While it's doing that, I asked it to fully annotate that prior function. Let's see this function. That's where deep links will be nice next in the future. All right, look at that. So we have, I can say, okay, you know, I still have more dummy functions in that function. I still have dummy variables, local variables, definitely rename them cleanly. Make sure we have proper calling conventions for the call functions and the prototypes. Again, this is something we repeat, so we can do a nice slash command. But here it is, for example, we have those nice comments across, and it has a nice function header comment. And I think the other dummy variables weren't necessarily used, yeah. And also look at, for example, you can see typecasts. So yeah, make sure you cover the proper types and apply them. And also, if there are magic constants, please introduce the proper enums for them and apply them. So what I'm inviting it is to get rid of this magic constant, and also to nicely recover the type around this guy. And we can let it work. Meanwhile, we can look at this one here, and here it is. We got our answer. How is that registry used? And here it is. I asked it from main, so it main dummy variable, dummy function, then it directly goes to xSQL, and it's not that far to reach to that registry key. So it's only 3 levels deep, etc. Okay, so use the annotation skill. You can see those dummy functions like sub underscore and so on. Rename them cleanly, and pick another registry key we haven't looked at and show me the call graph and how we reach it. Find something that's, let's say, 4 or more depths in level, like something more complex. So the path from main to that registry access, let's make it 4 or 5 levels deep at minimum. So here I'm asking a bit of a more complex question, and it was just a matter of time. Again, if you have a speedy model, this should be instantaneous. But you will notice it's just the model, and I'm using a smart model. Alright, so this is gonna get rid of, it's recovering the types, so it's gonna try to understand how that is used in order to fully recover the type. We don't necessarily, we can nudge the model to maybe guide it if we think it's not going in the right direction, or we can trust it and hopefully it figured out what it needs to do to answer that question. Meanwhile here, we have a clean reconstruction of main, and we got rid of the driver, so the driver is shut down. So first of all, the driver has been saved, the server has been shut down, the exe has been fully recovered, so we can basically also shut down the exe. But this is the exe fully recovered, and we're gonna open the driver, take a look graphically at the driver and see what's happening. So first, we're looking at that driver. Let's take a look. This driver is practically, we have the source code now. All those functions now, were dummy functions. They're pretty clean. Let's hit the decompiler and take a look here. So we have the comment here. We have this one, a binary status. We have functions called real driver entry. I'm not happy with this, but we can definitely ask it to change the prototypes. So definitely we can invite it for this. For sure, yeah, there's some work that needs to be done. We can ask it to do that. Let's connect visually. So we can say .http start. And now I can go back. Okay, so let's reconnect to the driver. This is the connection string here. And so what are my requirements? I would like, so there are still lots of casts. Also the real driver entry prototype is wrong, you need to fix it. I can see global variables and casts. This is clear indication of a structure of some sort you need to recover. And there's also access to unknown data elements as well. Properly understand what they mean and rename them. So get rid of all the local variables, rename them, recover the types, function prototypes, and so on. So here I reconnected to the same session because it has still the same context and gave it a new connection string. This time we're gonna do it in parallel. Here we go. And now we can see the progress of this. It's still answering the question about that database here. It still haven't figured out all the answers, so it's recovering the types and everything. Again, the slowdown is not the tooling. Here, about the driver, it successfully connected back to the driver with IDA open. So now it's gonna be collaborative work. We can work side by side. And it accounted for this. It's gonna figure out the function prototype and apply it. And I'm using medium efforts, just try to save on tokens. But if I use a higher efforts, it's gonna be way better and smarter. All right, so I'm gonna leave those here working and switch to one more last demo. So as I said, there's so many workflows we can do. And yeah, let's just go fresh. I'm not gonna touch any of those. Or let's do that. Let me take some random stuff. I'm gonna take this couple of drivers and these and make a new folder here and show you one last workflow. In this workflow, let's say I have a bunch of binaries here. I want to analyze all of them at once. I can say /connect, list the binaries in this current folder, and then open them in the background. And in the table, show me how many strings and functions each has side by side. Keep the servers open, I have further queries. So now what I'm asking it is to do multi-binary analysis. It could be the same architecture or different architecture, it doesn't matter. So by doing that now, the agent will do a quick plan and say, okay, I have those. I need to run 3 IDASQL CLI instances in the background and start talking to them. So it automatically assigns ports, whatever ports it needs. It spawns 3 agents here that is gonna be managing, and then it's gonna start querying each one of them and then present me with the result. Now for the settings or config, eventually we can turn off the verbosity. So as I said, we don't have to see the technicalities of the queries and what's happening. But there's nothing wrong with seeing what's happening. So eventually we'll get the answer. Here is still recovering the types. Okay, I think it found the type here. It's getting there. So for this one, already, I think, yep, here it is. It found it, it's dialog style. It even applied the nice this one, and it finished. I can say here there are still magic numbers you could have introduced enums for. So take a look and apply it. So here, for example, I told it to get it. This should be a std out uppercase. So here it already knows in the command, but I'm asking it to apply it, and it will. And this one, it would say is also std out. We'll see essentially. And here for the drivers, 5 levels down, not the driver, the same binary. When we asked it find who, pick some other registry key that has at least 5 levels down to reach it, and here it is. Okay, so it picked one registry key and it went all the way down, and this has 5 levels down. I can say, can you find the registry key that could be accessed 8 levels down from main, for example. But here it is doing that. And eventually this will be recovered and all of those will finish. Okay, so here it's still analyzing the bunch of binaries. I gave it 3 binaries in this folder. It's working on it, so eventually it will finish, and just once it's done we get the answer. I have already tried it with Chinese models. The speed is amazing, how fast things progress. You get your answers really quick. All right. So yeah, maybe in the next video I show you how we can get the source code completely. So here it is, by the way, the driver. I asked it to recover types, get rid of, change the prototype, and rename global variables. So this is essentially most of the driver. Now here as well, that's where the resource skill comes into play, because it hard codes all the prompt I'm talking about. Rename every single dummy variable, make sure you cover all the types correctly. So here I see verbose output false. So you see, if I hide the verbose output, I don't see the prompt. So let's try that. All right. Okay. And no more verbosity here. All right. So now I'm analyzing 3 drivers, by the way, and which I can say resource. Let's say for only the control to caps AMD sys driver, I want you to fully recover the compilable source code. Hey, let's do that. Let's give it a folder here. Let's create source here into source. Give me a CMake script. Make sure we only have a C file and header file and CMake script. The source code recovery should have proper type recovery, and no dummy variables or global variables, and 0 decompiler artifacts. Like this, it's clean, and also make sure it follows the proper driver development coding styles, and well reviewed and grounded in the decompilation. And use IDASQL as much as needed. Use the decompiler skill, the type skill, and annotation skills along the way to also affect your changes in the database alongside the source code recovery as I advised. So here I'm gonna ask it to give me back the source code. You see, this prompt is generic. If I save it, I can reuse it. I'm gonna up the effort a bit just to have better results. Let's just go for high for now and go for it. Now I'm gonna get back the whole source code of this driver with a simple generic prompt. You can reuse this prompt. It's not gonna be anything that you have to redo each time. But since I'm showing you from the basics, that's basically what it is. So yeah, this is the real driver entry. If I want the source code, I could have done the same stuff. And the same prompt, I could have copied it, and then I can get back the source code of this driver. So let's see here. I'm not gonna wait for them, maybe just for the source code recovery. Okay, about that binary and so on. Let's ask a harder question. Okay, so you found the registry access with 5 depths. Can you find maybe 8 or more depth levels? So now I'm asking you, hey, do we have something that accesses the registry from main, but we need to have 8 call depth levels? Meanwhile, this one is recovering. Okay, wow, really? I didn't finish yet. Yeah, of course. And I could have said use multiple agents. I wish I did. Therefore, we can speed things up and do things more in parallel. So this is also agentic coding techniques. It's not necessarily IDASQL or SQL tuning. But it's gonna figure out a way to fully give us back the source code, and eventually by the end of the task we should have the whole source code fully buildable. So this workflow is ideal if you want to recover lost source code, port from one platform to another, or just answer questions about a binary. If you have a question, you don't have the source code, you want to read stuff. I've had great success. I've resourced 100 kilobytes, 500 kilobytes, 1 megabyte. The larger the binary, the longer it will take, because the plan is going to be bigger. It's going to take a bunch of time to recover the types. But again, if you have a fast model, smart and fast, you will get results faster. But this is almost like almost deterministic process, in the sense that we rely on a decompiler, and with a smart enough model, you'll get better results than a human. Eventually, by the end of the day, once this finishes, we get the source code. So while this last task is still busy, I'm gonna just show you something as well, a gallery of vibe reversing projects that I shared. So in this repo, vibe RE, I make it like a gallery. It's just like to showcase, or a portfolio to showcase some of the capabilities. So I've showcased stuff using IDASQL and ghidrasql. So for example, I have some driver from sysinternals. And we got it to analyze the binary. It found the embedded driver inside it, and then it fully recovered everything. And I asked it to give me back, because this is a sys driver, figure out the IO control codes and write me a client code. Write me a library that I can programmatically use the same driver. This is a signed driver, so this is great. And we did the analysis, how it loads the driver and so on. Renamed. This is IDASQL, but again, it doesn't matter. Everything I've showed you right now, IDASQL or not, it's the same prompting. If you load Ghidra, you say Ghidra connect, and you're good to go. You speak the same way. Give me the source code, find cross references, find me call hierarchy, find me relationships. Is there any path between function A and function B? And if you had both Ghidra and IDA installed at the same time, then you can say, okay, I have one binary open in Ghidra, one binary open in IDA. Let's work together, transfer symbols between the two, or something else. So here, let's see the code. So this is the code. Okay, it's the driver. fully recovered. So this is what you expect if the source recovery agent is done. Here it's still recovering the source code. Now I have the full picture. It's figuring it out. And when it's done fully, we will have the whole sources. But to show you the quality of stuff, this is a fully recovered driver from sources. And here we have it figured out those guys. Those are the function prototypes, discovered types. So this is full type recovery. And this is the driver sources. It kept the copyright notice. This is fully source recovery for educational purposes only. These are the drivers. This is the proper driver development standards with the annotations here. Function prototypes, lookup object type, driver entry. And we can look at the common. Common is where the IO control codes are used both by the driver and the user mode components. So we have the device, DOS device name, the link, IO control codes fully recovered, nicely recovered, the types and the IO control structures, and the actual client code that you can programmatically use. It built us a client library where we can use that signed driver on our own. So basically all you have to do is this, driver check, driver open, etc. And this is we see here the IO control code formulation. So enable privilege, install the driver, and then the individual commands like, okay, that's how we send the IO control code. So we have one to check the driver version, one to query handle, we give it a handle, we know information about it. All they will be sent from user mode to the kernel, query process priority, and so on. So this was the handles utility, for example. That's a really simple demo. So the one I did for Ghidra, for example, with ghidrasql, I reversed 85 drivers or something like that, and gives us back client code essentially. So it recovers from the driver, recovers the types, and figure out what are the IO control codes, and gives us a client library. So if I wanna operate it, I can. So for example, nc host get physical address, read physical address. This is a signed driver, and if we deploy it, now we can read physical memory and do some stuff, and so on. This guy, let's see, the decompilation is clean now. So I asked it to do both, to recover the source code and also annotate in the database at the same time. So here it says the database is now fully resourced, and eventually it will start flushing back and recovering the source code. And remember, I was working with a bunch of binaries. I could have said, I would at the end say, good job, now do the same for the two other remaining binaries. And that should be good enough. And then like that, I could recover the same workflow, use it to recover for the other binaries. Look at that, it's starting to recover the nice source code. We can take a quick look here. So already now started to recover some constants. They recovered the custom device extension, driver entry, the dispatch. Soon it will follow by the actual source code, the CMake script, and off you go. You have yourself the source code recovered. I mean, what an age we live in. It's amazing. I don't have to prompt, because here I'm showing you the basic stuff, how you prompt at the basic level. You take that, you build a workflow, a bunch of agents, a bunch of prompts, and then maybe you just say slash, whatever slash command you use, your prompt is already there. It will invoke a bunch of your agents or custom skills. Essentially, then it's like 5 words. You can do whatever. Get back the source code, then pass it to a static analysis tool, and then do security review if you want, or do it at the binary level directly. So the really is your imagination. So this is the full source code now. Let's take a look at the driver. Let's see here. And let's open those. So this is the header file. Okay, we looked at it. This is the driver. Nice coding convention. Driver entry, fully recovered. Add device. I mean, this is maybe cleaner than the original source code. Who knows, right? I mean, look at that. What else do we want? There's no decompiler artifacts. There's nothing. That's the full source code. And as I said, everything I'm sharing with you is from actual experience. I'm not exaggerating that we can do all of those stuff. All right, let's wrap it up here. So I'll just ask it to shut down the server if it was not fully, if it was headless fully. Otherwise, if it was UI assisted, then you just simply close the database and save, and that's how you wrap it up. You don't do much. For example, here it finished the source code recovery. If I ask it to do this, use multiple parallel agents, and we should see it creating a plan, and multiple agents will work in parallel and so on. And then at the end, please save the databases and properly shut down the IDASQL servers. And we're done. If I hit enter at the end, we will get additional sources for those opened files that we opened headlessly. So for those binaries, so we already got the source code for this guy. We're gonna get the source code for this guy and this guy, and then we will shut down, have a nice annotated database. Let's try this and see finally before we wrap it up. All right, so we could even ask it, hey, put rp mgread power and so on. Power is pretty clean. Dispatch pretty clean. Okay, you say this is a simple driver. Yes, all right. You know, we don't want to spend the video waiting on the models to finish. But if you can afford a few hours, you can give it a larger binary, and you would see the power of this tooling. All right, so here I asked it, find me a path that acts as a registry, 8 levels, and it didn't. It did as much work as it can, but there's no such path. We can see it did a bunch of queries, joins, trying to look for paths, edges, etc. It even resorted to writing IDA Python code just to make sure if it can resolve it. And finally, no, sorry, at most I could find this and that, whatever. Here, now we can see it uses a parallel agents to recover the source code of those additional binaries in parallel. You're gonna burn a bunch of tokens, but trust me, a subscription goes a long way. And otherwise, you can, use the Chinese models. How smart! Wow, wow, wow. Yeah, maybe this is not the official one, the DeepSeek API. Probably it's the .com or something. Yeah. So you can buy APIs. This is way fast. Now, do you get the same intelligence as the American models? You have to try. They're not bad, but definitely they're cheaper. They respond faster. That's for sure. Alright, so what started as an intention to make an introductory video went beyond an hour, but it's fine, really. There's even much more to cover in this xSQL tooling. But I hope with this hour-long video, you get a taste of the power of the xSQL tooling family. Today we focused more on IDASQL, but again, there's nothing really special about IDA in particular. I'll show you a demo next time with ghidrasql and even more the related tooling to Ghidra. libghidra, for example, and so on. Even binary ninja, we could have done the same, get the same results. So just to recap, we went over the installation part, the philosophy, a bit behind the scenes, and a bunch of workflows. The most important workflow is the connect, which lets us either open the binary or binaries headlessly, and the connect as well allows us to pair with an open IDA UI instance or multiple instances. So if we have 10 IDAs, we can say connect, give it a bunch of connection strings, and we can work with 10 IDAs at the same time from our single coding agent. I showed you a bunch of techniques like finding relationships, who uses certain strings, what's the code path leading to those strings. We gave it a bunch of hard constraints. I showed you how to recover the source code cleanly and how to recover types, how to prompt it, and everything I showed you is at the basic level. Of course, what is left for you to do if you adopt those toolings is to build on top of it. But this gives you a good foundation to get started with the xSQL family. And a final reminder, you're watching this on the new channel, Binary Wizards channel, and no longer on the IDA, All Things IDA channel. So please, I appreciate subscribe. If you have subscribed to the prior channel, please go ahead and migrate to this new channel. All right, leave your comments. Thank you and see you next time.